So we will have now the discussion session. I try to summarize all questions that we can have. So first, perhaps we will start for some questions for engine and vehicle application. So it's a very precise question. For example, Dr. Wu, can you describe the injection strategy for dual fuel ammonia diesel work? Were these injected at the same time, or was the ammonia ejected much earlier? You mean if you can answer?
Oh, yes, I try. Thank you for the question. Injection strategy may be it's about direct injection case. In the case, we can apply early injection or late injection in the kind of strategy. We can do it, and we can add some another strategy. Some of the quantity is injected into the intake manifold, so we can supply ammonia indirectly and directly as well. So actually, we are planning to look into the results of the strategy. And at the moment, I think direct injection would be some advantageous effect on the emission control. I'm afraid that
Okay, also in the same order of question, as ammonia has a high heat of evaporation, which will cool down the intake when it is injected in liquid phase. Do you think that how it's possible to compensate the temperature dropped in the intake?
Yes, there is some heat addition to apply gaseous fuel into the engine. So we use the heat exchanger to heat up the liquid fuel, utilizing the coolant of the engines.
Okay. Do you think that try the spark igniter in diesel engine can help to reduce unburned ammonia emissions?
Yeah, I think it's about the species control for the NOx or NOx control. So in SI combustion, we have a stoichiometric mixture inside the combustion chamber. So we can expect lower NOx than other case. I mean, in diesel engine, we have a weak strength mixture. I mean, entire combustion chamber, usually we use a lean pure combustion. We utilize lean combustion. So in that case, we have plenty of oxygen inside, so we have much more NOx in GI engine case. So SI engine would be more advantageous to have lower NOx.
Yes, it's true. Last one. In fact, I think in one case you mixed ammonia with gasoline, and the question is about some phase separation may occur. If so, how it is possible to deal with this issue? And moreover, as ammonia evaporates very fast, minimum spark timing for mass torque is a function of mixture ratio. Can you provide some link about minimum spark timing for maximum torque as function of ammonia gasoline ratio?
Oh, this good question. But unfortunately, I didn't make any correlation with the ammonia pure mixing ratio or with the spark timing. But that's good. Yeah, I will try to do that next time.
Okay, thank you so much. There is also one question only, or two questions for Dr. Suda. During the liquid ammonia direct injection experiment, either radially or actually, did you run experiment at different injection pressure? And if so, how the increase in injection pressure affects the NOx emission?
Okay, thank you for the question. Basically, we use some spray nozzle, and basically the operation condition. I mean, operation pressure of the nozzle is it's used for only one pressure. So basically, we measure some spray behavior with a different nozzle. I mean, maybe this will be the difference with the pressure, but sorry, at the moment I cannot say that how does it affect the NOx formation. Yeah, maybe of course some degree of the spray will affect the NOx but today I don't have any data for that.
Okay, what will be the candidate position to inject ammonia for two-stage combustion in your 1000 megawatt boiler?
Yes, so this question is for the coal-fired boiler. So, so the boiler we have this is made by the steam tube, so by the wall of the steam tube. So basically, our customer does not want to make a new hole for the it takes a lot of cost to modify the tube, and also there needs an inspection. So basically, we think that we use some existing hole for the ammonia injection. This is one is for the burner, and another is some kind of a staging airport at much higher level. So right now we are trying to use burner to inject the ammonia, or maybe in the future, maybe we can use another hole for the maybe the staging airport to inject ammonia. But at the moment, for the 20% ammonia co-firing, we just use the ammonia burner. So we only have to modify the burner to change for the 20% co-firing. But I'm not sure about the much higher one.
Okay. And in the case of 50% ammonia co-firing, the developed low NOx burner for co-firing alone will not be able to prevent excessive NOx emission. How to prevent NOx emission when the co-firing rate is increased? Will the downstream facilities such as SCR be strengthened?
So for the co-fired boilers, for the SCR, right now we are thinking to just modify the existing one. So of course, SCR, we don't want to change the SCR really. So basically, our target is to make a same level of the NOx emission. And in our test facility, small test facility, we already tested for the 60% ammonia co-firing with the coal. And already the NOx emission is similar to the 100% coal. So basically, for the 60%, we think that it's okay for, we don't have to change the ACR in it. But I'm not sure about much higher one. Basically, if we increase the co-firing ratio, it will slightly increase the NOx formation. So I'm not sure much what happens on much higher co-firing ratio. But anyway, for the 60%, we think that it can be acceptable for not changing the ACR unit. Yes.
Yes, thank you. And could you comment also about the feasibility of ammonia production power plant integrating in a solar power plant? The question is about what are the key factors to make the ammonia technology as a competitive edge over battery storage system? And I think there is also another question. Can you compare also ammonia fuel to ammonia for SO fuel cell for power generation? What are the best solutions for your point of view?
Very difficult question, but of course it depends on the efficiency, total efficiency. And so, of course, to convert ammonia, to convert electricity to ammonia, and also ammonia to power, of course, we have to think about total efficiency. And I'm not sure, we never checked, but basically ammonia had an advantage of the storage for much longer duration and much higher, how to say, and much large energy storage. So I think that the purpose for the energy storage is different from the batteries. So batteries is much low duration, and not like a seasonal. It's daily, but for the ammonia, it's like a seasonal. Much maybe not like a month or a much larger long duration. And basically anyway, we would like to increase the efficiency, total efficiency, like to use some kind of electrochemical technology to convert power to ammonia in much higher efficiency. And also using the fuel cell, like a solid oxide fuel cell, of course, to ammonia to power, we have a much better higher efficiency. So anyway, I never checked, but of course there should be some advantage on some area. I mean, to much long duration or much large energy storage. Yes.
Thank you. And two questions also for Dr. Lanser. What about the formation of nitric and sulfuric acid after the quenching of the stream from the first stage of your combustion generator?
Yes, it's an interesting question. I'm just thinking about the measurements that we have done, and we did no particular measure on nitric acid and sulfuric acid. Those two chemical compositions you do not want in your installation because they may lead to severe corrosion problems. From the practical point of view, we did not encounter corrosion problems in the commercial supplied equipment during the year. So basically, on that experience, I would suggest that there is no forming of both chemicals in this process. But it also depends, of course, of the quenching medium that you're using. But I want to check that internally, this question again. And maybe I can give you some more comprehensive information about this question later. Is that possible?
Yes, sure.
Okay.
And another one, when you described your steam generation technology, the heat exchanger comes from, is heated by the ammonia combustion product themselves, or there is another approach? Do you have an idea of the total thermal efficiency of the system?
Well, the first part of the question is indeed that the heat exchanger will be, or the ammonia combustion products will heat up the medium that you have in your heat exchanger. I do not know by heart what the exact thermal efficiency is of the system, but it depends also on the design and on the temperatures that you are allowed to pass through this heat exchangers. So it's not possible to give a very clear figure on the thermal efficiency of this system. Sorry.
No, it's okay. And I think there is a question for all the speakers. There are some corrosion issues with some metals, plastics, and so on in these different applications, what they are. So you can answer, all of you, I think.
Yes. Well, shall I first start?
Yes, sure, Albert.
Okay. Yeah, we, like I said in the other reply to the question about the nitric and sulfuric acid formation, we did not encounter any corrosion problems related to the combustion of ammonia. So that's from experience from 2009. So more than 12-year experience, did not encounter much corrosion problems.
So it means that you have some special metals, or it's only steel?
We use steels, yes.
Steels. Okay, and from engine application or boiler, please?
Yes. Engine first, more ammonia is very reactive, so we have to carefully choose materials. So we have to use stainless steel or steel because copper or zinc will have a reaction with the fuel. And some of the, inevitably in the engine, we have to use some rubbers. So in that case, we have to carefully choose to avoid any corrosion issue. Thank you.
Okay, and
Yeah,
yes.
Yeah, from our experiment, during the experiment for the sodium oxide fuel cell, we had some high temperature corrosion problem. So around the temperature, so it depends on the temperature. Around 400 degrees C or 500 degrees C, the high temperature corrosion occurs by some kind of a metal. So, but for the burner, for our gas turbine or coal-fired boiler, we check the temperature at the outlet of the burner. So, but it's much lower because if the ammonia is basically it's the temperature injection temperature is not so high, and of course there's a radiation from the flame, but anyway the temperature of the burner outlet is much lower than the corrosion temperature. So anyway, basically we think that it's okay, but it's one of the issue or we have to care about. Yeah, it depends on the temperature. Yeah.
Yes, sure. I don't know. There is one more question. I think yes, perhaps. Oh, no. Oh yes, from Dr. Lanser. What is the operating pressure of the ammonia cracking unit that you present at the end? Can it be operated at high pressure to produce high pressure hydrogen in order to save some compression cost, for example?
Yes, I can tell you something about this. The operating pressure is kept as low as possible for cracking efficiency. However, some of the purification of the hydrogen requires a higher pressure. So it's a balancing between the different pressure requirements to choose the optimum pressure for the entire unit. So it's I cannot give you a single digit, but it's depending on several input parameters for which pressure we will design.
Okay, thank you. So I think Professor Dimitrios, can you? Oh yes, you are here. Professor Kevitsis, can you ask your question? I think directly. We cannot hear you.
Thank you very much, and thank you, Gaetano and Hong, whom I see, and Manny, and all the colleagues for including me in this. I was just wondering whether this is a good time for the combustion community to contemplate whether we want to keep our interest in small-scale mobility alive. it looks to me like an electrification and fuel cells will dominate urban and small-scale mobility. And no problem with that. In my view, the combustion community should focus on large-scale mobility.
I think we lost you.
Yes, Tim.
Yes, we lost him. And oh, yes, Professor Kiristis, can you try again because we lost totally you. And we have not your voice.
Sorry about that.
It's okay.
I was wondering whether, you know, we as combustion communities should keep working on small-scale mobility. And I think the ammonia case is a good way to look into this. It looks to me like small-scale mobility will go towards a combination of electrification and fuel cells. And we should reside mostly on large-scale engines, problems like auto-ignition, diffusion flames for large-scale diesel engines, and perhaps life cycle analysis, combining the DNOx with the combustion properties of ammonia. And also I was wondering, in these carbonless scenarios, whether our industrial colleagues have any insight as to how ammonia compares with methanol, which is another fuel that can be a synthetic fuel in a completely carbonless scenario. Again, thank you very much, and sorry for the connection problem.
No problem.
I'm not quite sure, but I think I have to start first.
As you want, as you want.
Thank you for the question. Yes, you have the trend exactly what you have. And so I most of the part I agree with you. So for the small mobility case, we have electric vehicles and hydrogen vehicles as well. So that's that portion would be increased a lot. And for the ammonia application, ammonia combustion will be a bit behind them. And I totally agree with that. And so, but in other questions, we see that how about we can store the energy, electric energy, in the form of gas, for example, ammonia. In that case, we can store the energy, and we can use the energy to produce electricity or the hydrogen to make hydrogen. So at the moment, we can focus on large-scale power generation or marine vessels, and I totally agree with you. But one thing, methanol has a another big candidates to deal with the decarbonization in the form of e-fuel. So that's another competitor for the large scale application as well. So ammonia is still one of the promising candidate itself, and it can compete with other fuel in the future, I think.
Okay, somebody else want to answer also to this or to do some comments about these questions?
Can I just make a comment in reply to Professor Kiritsis?
Yes.
And that is, I think, I mean, it's a very good question, but I think the answer is partly political because car, as I understand it, car manufacturers are forced to manufacture a significant proportion of their cars, of their light duty vehicles, as battery electric vehicles because they are considered as zero emission vehicles and car manufacturers have a total carbon that they can emit, and therefore because of that classification that the BEVs and the FCVs are zero emission vehicle because they work only on what's happening at the tailpipe, then car manufacturers have got their hands tied behind their back essentially because they have to manufacture a certain proportion, and that's part of a grander strategy essentially to drive out the internal combustion engine from populated cities and generate the power elsewhere on the fringes. So unless this classification goes away and you're really looking at the life cycle analyses, genuine life cycle analyses of battery electric vehicles as opposed to internal combustion engines, then the trend isn't going to change, and you're going to have in the short term battery electric and fuel cell vehicles essentially driving within cities as opposed to internal combustion engines.
I agree with you because I don't think that car manufacturers are very convinced about battery electrical vehicles. They have to do. They have no choice.
Yeah, agree.
To answer straight away to the regulations. But
Agree.
I think that they think that in future they have to find some other possibilities like hybrid with some thermal engines, and e-fuel will be one solution.
Yeah, but see the hybrids if you do a life cycle analysis on these, the hybrids compete very well with the battery electric vehicles.
Yeah, that's true.
But it's just that if you go along with the classification that the BEVs are zero emission vehicles, then there's nothing you can do about it. So
yes, but it's only a play with a regulation. But this it's only for 2 years, 3 years, 4 years, and after it will be finished. They have to find some other solution.
I agree, but that's why I said in the answer that it's a political exercise because it's a regulation of these processes, and it's not until I guess there is probably a turnover of batteries, of lifetime of batteries, and people start to worry about the degradation of performance and the disposal of batteries, then there's going to be a wake-up call. But that's probably another 8 or 10 years down the line.
Exactly. I totally agree with you. Okay, there is no more comments or question. I think it's okay. Thank you so much, the three speakers for industry, all point of view, for sharing some ideas on really recent results. Thank you so much, and I think it was also very interesting discussion panel. Thank you.
Thank you.
Thank you very much.
I think, Gaetano, it's your turn. But we cannot hear you, Gaetano.
So we're trying to take. Oh no. This way. Okay.
We
Anyway.
can't hear you, Gaetano.
We cannot hear you, Gaetano. No sound. Anyway, I think it's a break session. That's right. During 1 hour. Yes. So we can and we will start in 1 hour later at 11:30 for KAUST time. That's it. Have a good lunch for you.